And then we're trying to get a lamp that's broken off the glass, trying to get it out of there without problems, which is easier said than done. So anyhow, we've talked about three of the more typical type things. We've got the push buttons, the selector switch, a variety of pilot lights, and I think they actually came in sets of 10. So I've got
You got different
blue
colors?
and yellow also.
Ooh.
Okay. So cheap, I think I paid like $15 for a set of 10. I mean, think about that. That's cheap.
Is that straight from China's Finest, it looks like?
Now let's talk a little bit about the fuses. All right. I've got two different styles. Okay, although this doesn't say it, these are what they call fast flow fuses. All right. Here, I think there was 10 of each size, and there's 15, so I think there was 150 fuses. Yeah, 150 fuses. And I think I paid like $10 for 150 fuses. On the other hand, these are the slow blow fuses. Now, notice that there's a size up here. It says 5 star 20.
20 millimeter, 250 volt.
Okay, so they're good for 250 volt. You can see the different sizes. It goes anywhere from, let's see,
8 amp.
0.1, so 1/10 of an amp, a quarter, 0.2,
All the way up to 20.
0.5, 1, 5, 2, 3, 4, 5.
8, 10, 12, 15, and 20.
So there's lots of different, 1.5 that is. Okay, 8, 10, 12, okay. Now, these are intended for use with electronics, okay? They blow, if it says it's a 10 amp fuse, it'll blow instantaneous at 10 amps, or very close to it if not, all right? So they're intended, if you get to the extreme where you're going to damage the electronics, it's intended to open the circuit right now. On the other hand, now, the slow blow fuses, okay, these are some fuses that I put in there, okay, the fuse blocks. You can see they're cheap and dirty, all right? And the fuses here are the 5 millimeter. Okay, go back to that. Okay, it has it right here on the front also. 5 by 20 millimeter. So it's 5 millimeters around. Okay, so what's that? Well, it's
You're talking
25.4 millimeters to an inch. All right, so it's a little less than a quarter inch. Now, on the other hand, now these are the slow blow fuses. Each one of these packets cost me about $10. Okay, and these happen to be,
Now, when I'm looking at the middle of these, I see that these have like a little dot in the middle, if you will, or like a little, the other ones don't seem to have that little dot in the middle. Is that the difference when you're looking at them?
yeah, it's a very thin member.
See, the
Okay.
first kind doesn't have that dot. It's just a line. And the second one, oh, where are you going with that?
Well, this is kind of like a fusible link. When you get to a certain point, you melt the center, and that dot will disappear. Okay, it's some type of an alloy in there. Maybe it's a lead alloy, who knows? But you can see the difference here.
That's not that. That's different.
Okay, these are the 20 millimeter. You can see these in comparison. let's just pull some out there. So I purposely made these, I bought these in different sizes so we didn't mix them up. And you can see the difference in size.
Okay, so not only can you see the difference that one is longer than the other, but like I said, the first one has the dot in the middle that the second one does not have, and that little wire in the middle.
Right, they're also a different diameter, so you can't get them wrong. Now, so this would be a fuse holder for the 5x20s. I have here, obviously, a little step up. A fuse holder for a, actually comes with a fuse, believe it or not. And again, this is different. You don't see the dot in the middle of it. This might be a fast blow fuse. And well, anyhow, you can see that the fuse sits in there. I'm not really sure, just
kinda
looking at
clamps on the
it, how
top there.
I think the whole thing pulls out.
It looks like it clamps to the side, like this clamps up, and you can just like flip up this little middle thing. So it's got the little safety catch there.
Yeah, but I don't want to, that holds it in place also. That's
Yeah.
part of your contact surface. You don't want to break that off. And this particular one looks to have some type of a resistor in series with it. Interesting. Okay, so I don't know about that fuse block. It's a little different. However, is that the same size fuse? Hold that up to that one.
Very close in size.
Yeah. So same diameter and basically same, yeah, it is the same length. So it's 6x30. And I see you have to take the two screws out the end to get it out. Because you don't want to lose that. Okay. And that just sticks back in there. So you'd have to take it out, then it pulls out of the, once you take those two screws out, this piece comes off, and then you can do it. They make many, many, many different varieties of fuse holders and terminal blocks. All right, so what else do we have here? All right, so we talked a little bit about in your book, you see something called a limit switch. This happens to be what they call a micro switch. All right, it's very small. You can see the terminations on the back there. So this would plug into something. And there's a little arm here. I doubt if you can hear it. Maybe you can. But as we push that down, it's opening and closing the circuit.
Red thing. Yeah.
And it's got what they call a Form C contact. It's very difficult to read. Maybe you can read it better. But it should say like one normally open on one side, and normally should say NO.
So it says on the bottom we see a label of 1, 2, 3 for each of the prongs. In the middle it says 5 amps, 125, 250 volts, wavy sign, 10T85.
Okay, does it say anything about?
And then on this one, the very first one here, oops, very first, says NC, normally closed. The second one looks like NO for normally on. And then the last one, it looks like, is that a G?
Yes, how about a C?
C?
Okay.
C or G, something like that.
So that's what they call a Form C contact. And the
Yes, a
the
C.
back one is common to both the normally open and the normally closed. So you can use this in either way, or double up on this, and you can use one contact, one normally open and one normally closed contact. But typically, these are cheap. These are real cheap. But when I get into industrial grade limit switches, man, you can spend $100 for something like this. And I think I bought a bag of 20 of these for $5, something like that. So single pole, double throw, one normally open, one normally closed. Okay. And yeah, thank you, China. 3 pins, 10 pieces. But super cheap. What else?
Fast.
Okay, here I have a time delay relay. Oh, before I go there, I want to show you something. All right, this is what they call a DIN rail. Okay, it looks like
About what, a foot
strut.
long?
All right, what you do is you mount this inside an enclosure, and all these neat devices mount on there. Okay, you can pull them out. Anyhow, they all basically mount on the DIN rail for the same size. Okay, and I have some relays, but I only bought a couple and I've got them mounted elsewhere right now, but we'll talk about them. Now, time delay relay. This particular one is what they call a time delay dropout. The only reason I know that is because of the part number. When I bought them, I have 2 of these. The A indicates that it's a time delay pickup, meaning that once you energize it, it'll time out, and then it'll close the contact or open the contact. It'll change the state of whatever the contact it is you're having there. Okay. This particular one, what it does is it will change state. It's energized, and it doesn't do anything. It's when you drop out or de-energize the coil that it starts timing, and then will change state. All right, so it's a whole different ball game. This changes after it's de-energized. The other one changes after it's energized. The pickup after it's energized, the dropout after it's de-energized. All right, so that's a difference. But anyhow, all the relays, the fuse blocks, where do I have that? The fuse blocks, they all mount on the DIN rail. A little pull-out thing there will allow you to mount it. I don't want to break it right now. But the relays are the same way. They all mount on the DIN rail. Here I have what they call a high-density terminal block. Okay, this only do up to about a size 14 wire. I believe it was 14, 16 wire. So it only really handle one wire in each side. And you can see on the inside the metal components on there. Now, because they're so small, you can fit a lot of them together, but because they're so small, you also have a tough time doubling up on wires. Now, for example, if we look back at our wiring diagram, let's look over here a minute. If we look back here, I've got 1, 2, 3, 4, 5, 6, 7. Wait a minute. 1, 2, 3, 4, 5, 6, 7 connections to the high side of the transformer, or I should say to the hot side. Okay, and then looking at the other side, I've got 1, 2, 3, 4, 5, 6 connections to the neutral side. All right, so knowing that I'm only going to get one wire into that terminal block, okay, I need a way of multiplying my connections. So what we do on there, I wanted to save this till later, but I think I'm going to show you now. One over here. So I've got here's some of my relays, by the way. This is a control relay here.
And that's all on the little
Okay,
thing on
it happens to be, again, mounted on the rail that's there, and they're what I call plug and play. You take the relay and it mounts, goes in, oh, I know why, it's got a retainer, and I just pulled it out of the retainer.
Okay.
No, not really. However, just to get an idea here, it'll show you you've got coil connections right here. You can actually see the connections going up to the coil being on the inside there. And then you can see you've got a form C contact. So it looks like you've got 2 normally open and 2 normally closed contacts in there. Okay, so with what I've got there, actually I'd probably end up needing 2 relays, because if it's only 2 normally open and 2 normally closed and I need 3 normally open, I'd have to get a different relay. But that's life. You can buy them. The nice thing about these particular relays is they're, like I say, they're plug and play. You can buy them in any configuration you want. You can buy them for any different voltage you want. And they're simple. One goes bad, pull it out and replace it. So again, goes back in there, snaps in, and it's good to go. So you can see all those are mounted on that one DIN rail. All right, now we were talking about multiple connections to certain points. In this case, I have this set up. One of the wires coming over here, this is my neutral, okay? So I have 2, 4, 6, 8, 10 connections to the neutral there. And it comes in on one side, and then it's jumpered. There's a jumper block that you can stick in there and tie all those blocks together. You see here would be the hot side. It's not really connected yet, but the hot side has 2, 4, 6, 8, 9. Oops. Yep, 2, 4, 6, 8, 9 terminals. And again, they're all jumpered together. So you got those little jumper blocks there. Makes it pretty convenient. All right, that I think is what we're going to cover for tonight. So we'll be back tomorrow night, and we're going to talk a little bit about the power side of it. We're going to get into the transformer. We're going to get into the starter. And we're going to talk a lot more about that. All right, so that's it for tonight. Enjoy it, guys. Hopefully it's a little different from what you've seen in the past couple of days. Let me know if you like it. All right? Thanks.
good one.
Have a good night.